This is the Python Final Lab Problem 3 explanation presentation by Max Psihos, David Peck, and Josh Keller. All right, let's see who gets the next. There we go. The overview of this code is designed to demonstrate long-term borrowing decisions for the user, where small rate and term changes materially affect affordability and total interest paid. It's basically an amortization schedule. And for example, this could be used for mortgage loans, auto loans, student loans, car loans, and everything else. It basically signifies a what-if analysis based on user inputs. The program is designed for anyone who needs to understand how loans work and repayment schedules, amortization schedules impact long-term cost. This means that under the amortization schedule, if you were to input different interest rates or twist or trigger something else, you might see a different different long-term cost, meaning that your interest might compound over time. Examples include, but not limited to, small business owners evaluating PPE financing. So if they're purchasing new inventory or new equipment or new land or anything like that, they can put in the loan schedule to see what their monthly payments are going to be. Researchers can adjust interest and period to see kind of different outcomes of the loan and the combinations of the two. And then another example is software developers, where they can take this code and implement it into a much larger code or a much larger model as just one small part. The business value generated for users relates to like better decision making overall. There's no buyer's remorse. So if you're able to test every single scenario that you are expected, then you can see your best output and pick the best choice for you based off your budget and risk tolerance. The simplicity of the output of the visualization allows for the quick understanding for the user. And so they are able to reiterate and go over and over and over as many times as they would like. Did you say the title? Did you say we use Quantlib or no? No. Okay, that's right. We'll get to I'll just say it right now. So just click the play button. Resume. Yeah. Here is a description of the package we used called Quantlib. Essentially, Quantlib is a quantitative finance library encompassing tools for financial modeling, trading, and also risk management. And some of the key functions of this package that we also use in our code that we'll explain later are essentially for calendars and day count conventions. So using like United States and also a complete schedule. You can also use market indices, so overnight indexes. We also use in our code instruments, so fixed rate leg or the fixed rate of loan. You can also do zero coupon bonds and also do the consumer price index. And as well, there's some risk measures and analytics. So if you're predicting cash flows over time or doing essentially what we do in our code, the cost of a loan over time, you'll be able to see that using the Quantlib package. Good stuff. Just cuts to that. So, Professor. The title slide is that theme picture. Yeah. Just switch it. Switch it to the middle fingers. All right, now taking a look at the approach that we used for this problem. We kind of wanted to create a line of code that could be useful in our lives. Obviously, taking out loans for things like homes, cars, whatnot is something we could do. So just kind of something that we could kind of mess around with and toss different numbers in there and just see what pops out. Started out by creating the initial if-else statement, just to obviously make sure that we printed the rules we wanted. Obviously, you can't get a negative loan, so we wanted to make sure no negative numbers were input into the loan value. And then just wanted to make sure it's still printed normally. Didn't want to like stop the code completely just because a negative value was input. And then, as mentioned before, the package we used was Quantlib. Just made sure that kind of developed those functions that would help display the information we wanted as far as the mortgage schedule value returning function goes. So there's a lot of different things that went into kind of creating those monthly payments and whatnot that were all derived from the Quantlib package. And then, yeah, obviously, like I said, we wanted to be able to have that be a value returning function so that we could easily call back into the main line and kind of just have it be a cleaner looking code as well as a cleaner running code. And then finally,
the final part was getting those graphs created and produced. This was the visualization aspect of this code. We wanted to kind of show what the life of the loan would look like over the inputted amount of years. And then also kind of added a little bit extra part to add points to the graph to kind of show the value of the loan at 2 year increments, just so the graph is easier to read and follow. So you're not just looking at a line with numbers at the start and end. And then finally, just went through and kind of formatted everything to make sure all the pieces we created separately worked together. And just, yeah, made sure indentation was all correct and everything ran smoothly. And then we went from there.
Nice.
There we
Fist
go.
bump.
Mm.
All right, halfway there. David, back up. David, as much time as you need to go through the code.
Yeah, can we see like what time we're at or no? I have no idea. I don't think you can.
That was maybe 3 minutes.
Yeah, I was saying we started at like 54, 55, I guess, to go to the code. We're about to do it.
That's not right. Thank God.
That's right there. Talk about this first.
Yep.
Just
Just the inputs, yeah.
okay.
Like here's the we need just like we needed different user inputs and be able to do the amortization method. So here's your monthly input floated in.
It says your screen sharing is paused.
Yeah, because the
Oh, the actual thing is paused.
yeah, the actual thing is paused.
Okay. Okay.
Yeah. Take it on, you want.
So here we have our user defined function, basically getting all the user inputs in terms of their loan amount, interest rate, and the term length. So firstly, the user inputs the loan amount, and then we make sure that this loan amount is greater than zero, so they can't input any negative numbers. And then secondly, the user will input their interest rate as a percent. So you're not doing decimal points. If it's 7%, you simply just enter 7. And then lastly, the user will input the years, so the term length, depending on which will show down here, which will give you the final monthly payment as well. And so, yeah, I didn't know what else to say. Yeah, that's basically it. Yeah, so.
Yeah, and that's this explain like the Quantlib, so it's like yeah, this like pretty straightforward. After using it from the take out this
Yeah.
do some bullshit.
And then the next part was getting the Quantlib stuff in that would be later called into the mainline function. So just taking a look at kind of some of the Quantlib functions that were used. Obviously, to set up the dates, we used functions that create a calendar based off of US government bond holidays. And then moved on to schedule of the payments. Just wanted to obviously make sure that the sequence of payment dates for the loans or whatnot was inputted and was shown later on down kind of by the graph. And then jumping to the fixed rate loan, the fixed rate leg function, which just creates a list of scheduled cash flows based on some of those loan terms that went into that schedule.
function. And this was also something that was shown down below by the graph to kind of get an idea of what it was Quantlib was producing, and then also give an idea of kind of what some of those fixed payments would be. That's going to be the best I'm going to do with that.
That's it. You're in the clear. You're done. Oh, warmest chair I've ever sat in. So let's see.
Stick behind them to finish it.
Here we go. All right, so to define our calculation down below, after we have accumulated our user inputs and Quantlib has defined our parameters for the equation, we can see the first thing that this calculation does is it takes the annual rate and it divides it into a percentage, then it divides it into 12 months so we can have a monthly rate. We also convert our end payments from years times 12, so we can convert it into months just to get like terms. Our monthly payment formula is our new amount, which is payment, is equal to the loan amount inputted by the user times our new monthly rate that we got up above by dividing the annual rate times 1 plus the monthly rate again, same thing, annual rate divided by 100 divided by 12 times end payment, which is the amount of months that the user inputs after it's converted from years times 12. And then that overall is divided by 1 plus the monthly rate again, times the overall period minus 1. We then have a account controlled loop here for I in the range of end payments. So based upon the user's input, we are able to create an interest amount. So interest is equal to the remaining balance times the monthly interest rate. So the balance again is inputted or just known from the equation. Principal paid, same idea. It's payment minus interest. So whatever you don't pay in interest, it goes towards your principal payment. We can then reduce our remaining balance by each of the principal payments made each month. That's how an amortization schedule works. Your principal goes down after you pay off your interest. And then we can append the list that we made up above with the accumulator variable that equals it to 0. After we append that list, we are able to return payment and balances. And now just do the graph and then just run it.
Run it.
Sample things like $10,000. 10 G's, 6%, 10 years.
I mean, we're doing a home loan, so should it be like more?
Yeah, you can do a million.
I'll just do like 500,000. And then this last part of the code prints the graph that I'll show you in a minute. So first we can see we title it the home loan balance over the years. X label will be our month, and then our Y label will be the remaining balance of the loan. And then as well, at the end, the user is able to try another loan if they wish. So let's run. Oh, it's because the one wasn't filled out. Okay, so I'll do this again. Okay, so here we'll run the code. Let's say we have a $500,000 home loan at a rate of 6% over 10 years. We will input 500,000, 6% interest rate over 10 years. And here we can see the remaining balance of loan from the beginning, and then for a total of 120 months at 6%. And then if you would like, you can enter another loan, but for the sake of this presentation, let's just say we end it there.
Good job, boys.